Oh, hold on. An error occurred. Please try again later.
Oh no.
So there's chat going on the video, but it
Yep, I
just
see the
says an error
chat.
occurred. So
So if there's any time that the world needs to tell us that we exist, now is the time.
Ah,
Wait, Astro B. Oh, I see. Astro B said hi to you, but then I
saying
realized,
hi.
yeah,
Uh,
said hi to you in the.
yeah, Nancy just replied, said that she's not seeing it. It's messed up for her too.
Yeah. So if this is messed up, then we will just do a private version of the show, and then we'll upload it at the end.
okay. That's new.
That is new. Yeah, this is brand new and fresh to me, but like I said, I'm able to record it. So this is like existential. Is this the apocalypse?
Slowly, the whole internet comes crashing down. People run
Yeah.
outside their homes, start
Long as
lighting
the sun
torches
comes up
and
in the morning.
shouting.
As long as the sun comes up in the morning, I'm good.
Buildings start burning. Fireworks and chaos.
It's like the scene out of Airplane. You know, we have all these issues. Also, we have no internet. Ah!
Oh no. Okay.
Gotta engage the inflatable autopilot. I haven't seen that movie in a long time.
Sure, I've seen it.
Wait,
Really,
someone sees us.
What?
Yay!
Yeah.
Hello, world.
Okay, let me refresh the page. Nope, I'm still getting an error.
Ugh.
So
So it might be down for some people and up for others. So
yeah.
yeah. Well, if anybody can hear us, put it in the chat. We're very curious
Okay.
to know if
All right.
anybody can see us.
Shirts are available now. If you want to check them out, we have our own.
Oh, sorry. One of my videos started working again.
Good. Yeah. Be careful. You've got like a whole bunch of videos all queued up, ready to go.
Just the one. Just the one.
Yeah. Uh, yeah. Okay. Well, I'm gonna leave the stream running
Okay.
in case because it says it's working. We have apparently 3 viewers, maybe 1.
Well, maybe it'll go back up while we're talking. I'll put a note in here to able to periodically refresh your
Yeah,
page.
that's what I'm thinking.
take
So
it.
okay. Yeah. Nancy has had enough of 2020. Show now. And
Like, can't we just have one thing? Just one thing.
yeah.
That's all I have.
Yeah, live in chat only. Okay, that's the other options. We just do the show in the chat.
Oh, that
Yeah.
sounds awful.
Hello
Okay, I got
and welcome to the weekly Space Hangout. Oh, this is gonna get old. Okay.
Look, somebody's singing
Like Kermit the
99 starships waiting to launch. 99 starships to wait. Take and fuel, light the candle. 98 starships waiting to launch.
Okay. All right. We're professionals. We're at the 5-minute mark. We can't stop time, so let us begin. I'm gonna put you
Yeah.
all back into your boxes. I'm going to wait. Andy Cowley sees us. Okay, this is nonsense. All right, here we go.
Well, record it and the show must go on.
Exactly. That's exactly right. All right, here we go. I'm pressing record. Oh, there you go. James Platt sees us. All right. You may or may not see us at some point during this show. Here we go.
I don't see a record, Fraser.
You won't see the recording.
Okay.
Yeah. Hello and welcome to the weekly Space Hangout for Wednesday, November 11th, 2020. I'm Fraser Kane, publisher of Universe Today. This week, we're going to be talking about a Trojan asteroid with the same signature as the moon. Just a bonkers month for astronomy. The first fast radio burst seen in our backyard, Europa glowing in the dark, and maybe more. We have no idea if people are going to be able to see this live. Joining me this week, you're on my screen right now, Pam Hoffman. Hey, Pam, how's it going?
Awesome. Thanks so much, and happy Veterans Day, everybody.
It's and we have Remembrance Day here in Canada.
Very
So
good. Okay,
same-
yeah, that's a U.S. thing.
Yeah, but it's the same. It's the same thing. A day that we take a break and think about all of the veterans who sacrificed themselves for Canada, for Queen and country.
Awesome.
All right, we've also got Dr. Brian Coberline. Brian,
Hi, everybody. Good to be back.
good to have you. Oh, everyone's shifted down. I think I was. There we go. All right, you're more balanced now. And we've got a new co-host this week, although she's not going to be new to everybody, and that's Molly Wakeling. Molly, welcome to the
Hello.
Weekly Space Hangout.
Thank you. I'm glad to be here.
And for people who don't know, let's get the introduction. Who are you?
So I am I'm a PhD student at University of California, Berkeley, studying neutrino physics in particular. And I've been doing astrophotography for about the last 5 years and have been a super fan of astronomy since basically forever.
So I didn't know. I mean, you've been just a font of knowledge for the virtual star parties, but I didn't know that your specific background was in neutrino research.
Yeah. I'm only a second year student, so I don't have a whole lot of time under my belt yet. But that's what my research specialty is going to be in with the Snow Plus collaboration with the Snow Plus neutrino detector up in Canada.
That's the one in Sudbury?
Yes, one in Sudbury,
Right. Okay.
deep underground.
Yeah. But you haven't had a
Right.
chance to go down to Ice Cube yet.
No, I going to Ice Cube would be super cool. Yeah.
Yeah.
My group, we don't do work with Ice Cube in particular, but it'd be cool to see that someday too.
Yeah. That's on my bucket list. Brian, was that on your list of big observatories to go visit?
Oh, sure. Yeah. Just send me down to Antarctica. I'd be happy to go.
Yeah. Well, but you know, on your big science show,
Yeah, that's exactly it.
that's got to be on the
Season
list.
two. Season 2.
Season 2, right. All right, well, before we get on to this week's guest, I just want to remind all of you to go and join the Weekly Space Hangout crew. This is the incredible community that surrounds us and joins us here on the Weekly Space Hangout. So they are our executive producers, they are our fans, they are our friends, and it's just one of the best communities you can be a part of. So if you want to join this, go to wshcrew.space. Go there, they'll give you the instructions how to become an executive producer of the show, and then you can bring on cool special guests. And speaking of special guests, this week we've got Amy Ross from NASA. Amy, welcome to the Weekly Space Hangout.
Well, thank you. I'm happy to be here. This is new for me.
A Zoom meeting? Have you missed 2020?
No, the Weekly Space Hangout. Thank you
Oh,
very
okay,
much.
all right. I thought that maybe you somehow shifted from some other dimension or something, but no, that does make sense.
No, I've adapted.
Yeah, we all have. Yeah. Well, so who are you and what do you do?
Right. I'm located at the NASA Johnson Space Center down here in Houston, Texas, and I am the Pressure Garment Subsystem lead for the Exploration Extra-vehicular Activity Unit. So I work on the people-shaped part of spacesuits. That's what I do.
The people-shaped part of spacesuits. Right.
Yes. Versus the big, giant, heavy backpack. That's another guy.
Okay. I see. I understand. All right. So this is great. I mean, we're in this transition time. I mean, obviously, I think everybody is familiar with the ACES suits that the people wore when they flew on the Space Shuttle, the orange suits. We're familiar with the suits that the astronauts wear as they head outside the International Space Station. I've got to assume that as people are planning to go back to the moon, someone is thinking, what's everybody going to wear?
Yeah, and I'll tell you, but I gotta let my cat in real quick.
Sure, yeah,
Sorry.
absolutely.
He's like,
Oh, and I didn't.
Latest passion.
Yeah, yeah. We stopped this show for cats, no question.
Space kitties.
I'm sorry about that, but he's very loud. Otherwise,
She muted herself.
You muted yourself. I can unmute. There we go.
okay.
Yeah.
So, my job is and has been for a long time is developing new spacesuits. So there's a group that works on the current spacesuit that flies on the International Space Station, the Extra-vehicular Activity Mobility Unit, or EMU, ISS EMU, right? And there's also another team that works on the crew survival suits, like the ACES, and now the next one's going to be called the Orion Crew Survival Suit, or OX. But I work on EVA, extra-vehicular activity suits, so the suit you wear when you go outside of your vehicle, exclusively, and been focused on planetary configurations for most of my career.
That is the coolest thing ever. So specifically, you're focused on building spacesuits for people who are going to be walking around on other worlds.
Yeah, that's what I do.
So what did we learn then from the Apollo missions that has informed your designs?
One of the key things I think to keep in mind is that that suit did 3 jobs in one piece of hardware, basically. So it was one of those crew survival suits, like the ACES that you did launch and landing in emergency situations. It was also a planetary surface EVA suit, right? So you went outside and bounced around the moon. And also in some changes, just minor, they did microgravity spacewalks in that suit as well. So we tried during the Constellation program, which was a few years ago, kind of the 2005 to kind of 2011 kind of time frame, to try to mush all those together again, all those jobs, but increase all of the capabilities in each of those jobs. Well, it's like if you want to build a Formula One race car and have a very capable dump truck. If you try to mush those two together, there's going to be compromises.
It's possible you're describing a previous space vehicle, but anyway, let's talk about spacesuits. So what are the roles then? I mean, you've got what the people, and you mentioned this, that there's the Orion, right? So there's the people that are wearing a suit when they're in the Orion capsule, and that's not your specialty. But you're saying that there was the plan to potentially merge those together, that you would wear the same thing in different situations, and people have been talked out of that.
Yeah. Well, and so we tried to do that during Constellation because there's some benefits, right? If you only have to take one suit on a mission, it saves volume, it saves mass. All those things are really important to spaceflight. But the difficulty is they also wanted improved performance on all fronts. Well, when you compromise, you definitely then sacrifice some performance. And so you couldn't combine those functions in one piece of hardware. So that's why the Orion capsule has a crew survival suit specific. And then we are getting to build a specific EVA suit for planetary surface. Now that suit will also be capable of doing microgravity EVAs as well, because we'll take it to the International Space Station, probably try it there first. But we've done some testing on the ground to show that this configuration is fully capable doing microgravity EVAs without compromising too much of its configuration toward, away from planetary surface EVAs. So when you separate the crew survival job and the EVA job, you can do a much better job on each.
And so what are the primary requirements that you're looking to accomplish with this suit?
Yeah, well, so most of my career I didn't have a specific mission. So I was focused on, what's kind of the big job. And the big job is a Mars mission. And when you think about a Mars mission, and if you watched or read The Martian, you know that the unexpected happens and you've got to be able to deal with it. And so in that case, we try to provide the human with as much human capability as they have unsuited suited. And so mobility is a big deal. And so when we're looking to build this moon suit for the 2024 missions and then following lunar missions, we're trying to think forward to that Mars situation. So we're trying to provide as much human capability in this initial go, so that if you need to kneel, you can kneel and pick something up, which they really couldn't do during the Apollo program. I mean, they fell a lot, and part of that was on purpose because that was the easiest way to pick something up, which is
Just
terrible.
fall over.
But it was right, and they did.
Right.
If you watch it again and again, it's like, oh, I gotta get down there. And then if you want to really walk and be capable of walking for greater distances or more routinely, then again, more natural walking's needed. More stable walking's needed. Less falls are a good thing, right? Those kinds of things are what we're focused on.
And I mean, the conditions are, the gravity is different. So I wonder, if you are on the moon, you can support more spacesuit with your muscles than potentially on Mars. But also you have this awful dust. So does that change the requirements at all between the moon and Mars?
Yeah, so suit design is predicated on where you're going and what you're doing, right? The where you're going part is, all those environmental constraints. And then the what you're doing part is, what kinds of activities do you need to be able to accomplish? The more you know about each of those things, the better you can design, right? So, it's like packing for a vacation. If I know I'm going to the beach in Fiji where the temperature's this, and I'm going to be doing these activities, then you know exactly what to pack. Well, same thing. The more we know about where you're going and what you're doing, the better we can design the suits. And so we pay attention to those things. So we're learning a lot about, one of the fun things about my job is I'm always learning about all these different things. I know a little bit about moon dust. I know a little bit about Mars dust. I know a little bit about vehicle dynamics. I know a little bit about geology tools. I know a little bit about how to do field geology. I know about my fabrics. I know about, my life support system. All those different things is part of what makes my job fun.
Yeah. Now you brought some pictures. And normally I try to talk people out of this, but these pictures are awesome. So why don't we take a look, and I'll share I don't know if you can see, there you go. So it might be backwards, but don't worry.
Yeah. So
where do you want to go?
Yeah. So that slide there just basically said kind of what I've been saying. Spacesuits, well, when you think about them, some people think of them as more like a costume or a uniform, but really it's a life support system. That's what keeps you alive. And then we have to think about, again, where you're going and what you're doing when we try to keep you alive. And then our suits that we're building are going to look different than what you're used to seeing. Mm-hmm. And so if you scroll down to that slide, that's a rear entry walking configuration suit. And so it has a lot of mobility features, a lot of bearings, basically, that allow rotation of a pressure garment so that as you move, it's like when you twist a balloon, right, and you let it go, it goes right back to the same shape it was. Well, so you're inside of the balloon. So if you don't give a bearing there so that you can move that joint, you're always fighting the suit, which is what they had to do during the Apollo program.
Right.
Making it easier to move. And you can see there we address that dust is something we have to pay attention to, because with all those bearings and then putting it in a dusty environment, you have to keep the dust out of those bearings so it can move. And this is a series of different suits that we've looked at over time, trying to understand a good way to design a planetary surface suit. And each of these suits has some different features associated with it, different things we tried out, different construction techniques, sometimes different materials. And so the Z2 there, the gray suit on the end, is the suit that is the closest to how we're moving forward going onto the moon. Yeah, we got the Mark III back in 1989, and we got the Z2 in 2015.
Right.
And this is just another timeline that shows you kind of that time.
And so those are all the different spacesuits that people wear.
Yeah, so there's that orange suit. That's the ACES suit that you were talking about.
Yeah, the EMU.
Standing next to the Apollo suit, right? And then the shuttle station EMU, same basic thing, is there with the red stripes on the legs. The Mark III, that first prototype we had in my picture before, is there next to her. And then there's some of the other suits. The blue suit is another crew survival kind of suit, and then the suit on the end is the Russian crew survival.
That's a Sokol suit, right?
The Sokol.
Yeah.
Yep. Yep.
Excellent. And this is interesting. So this idea of going in to the back of the suit, that requires some.
Why do you think we do that?
less things to put on. One place to close up.
Well, there's still a helmet and gloves to put on, and the other suit just connects at the waist versus a rear hatch.
All right, I have a theory.
So,
which
Is
is
it easier?
Okay.
Amy?
no, you attach it to the outside of your spaceship, and that way you don't have to go in and out of an airlock.
that is a potential option, but that's not what drove the suit. This suit
Okay.
design was driven to be reentry based on mobility.
Right.
So have you ever tried to put your shirt on without unbuttoning it and get up in it? Right? And you get stuck, don't you? Well, if you do a waist entry suit where you have to kind of get your shoulders up through there, you have to move the shoulder bearings of the suit out away from where you really want them to be. So when you do a rear entry suit, you can keep those shoulder bearings where you want them so you can get full range of motion in your shoulder. And that means that you aren't compromising the shoulder mobility just for the donned off. So then the rear hatch is the way to get in to leave those shoulder bearings where they're most mobile, basically.
That's really cool.
Yeah.
And then I don't know if there was a video there. Didn't come through.
There is, yeah, but not on the PDF.
Yeah.
It's too big to send.
Yeah. Good. So let's go back to you then and shift that. So I guess, I mean, at this point, it's funny, like when people talk about when they talk about the Artemis mission and they're like, are we still going to make it for 2024? I'm like, well, hopefully, but there's like a checklist, the length of which you can't even wrap your head around. And I talk about how are they going to eat, where are they going to go to the bathroom, and what are they going to drink? And then I say, and what are they going to wear? So do you feel confident at this point that you know what they're going to wear and you've got their outfits on track?
We were doing really well, but right now, because of our budget situation, we're under continuing resolution, and that we expected to go up multiple times in our budget amount this year to be able to meet our schedule, and that's not happening right now. So we had to stay at last year's budget level, which was lower,
Right?
And so that does slow us down. But sometimes that's not all bad, because then you get to breathe and think a little bit and make sure that you're making some of those decisions and get a little more coordinated, a little more organized, because they just started the human landing systems project not too long ago. And so they were ramping up, and we were blowing and going. And so now we're trying to do a lot of that coordination between the two. There's a lot of interfaces that we have to deal with, correct? And so we're getting to do more of that talking now.
It's an interesting challenge that, like, you get into a spaceship on Earth and then you fly out to space and then you transfer to potentially a spaceship that's flying around the moon or near the moon, and then you get into a different spaceship and then you go down to the surface of the moon, and then maybe you get out into a different spaceship, and then if you want to leave your spaceship, you put on a tiny little spaceship. At every point, you're just shifting from enclosed environment, personal, from larger spaceship to smaller spaceship, depending on the need. I mean, each one of those has its risks and its downsides. It sounds like it's a tricky problem that's going to be forever causing us grief as we try to explore space.
Yeah, we take that very seriously and we manage that very carefully. I'm on, I don't know, hour probably up in the 80 hours or better of safety reviews, just this go, right? We had an earlier phase and we're in another review of safety review, another phase. And so we go through each thing that could happen, and we talk about it, and we talk about how we're controlling it, how we're verifying those controls are in place so that we can minimize the amount of risk that we're taking. But there is a risk. I mean, you walk out your door, there's a risk, right? But now we're sending humans into a environment that we are not in any way, shape, or form adapted to live in.
Different risks.
And like you said, we're a little bitty spaceship, and we're sending people out in it, and we have to make sure that spaceship does its job.
But it's like you have to pack everything that the human being needs to survive. Every part of the spaceship needs to be in this suit. The heating, the cooling, the the oxygen,
Nutrition.
the
The
nutrition,
drinking water.
a way to keep the
batteries.
sweat off your face, a way to scratch your nose. I mean, just everything has to be part of this tiny little spaceship. And so it's, I sort of imagine your job is just as complicated as the person who's designing the Orion, but it's also smaller. Oh, right.
In some ways, I feel like it's more complicated because it does seem small enough that you can kind of wrap your hands around it. I mean, literally. Because when you're designing a vehicle, there's somebody is putting it all together, but you usually have a smaller piece of it. I have the entire pressure garment, and that's mine. And then that connects up with a life support system, and then you have a spacesuit. And so there's just, two leads that are responsible for the two major parts of this spaceship. And so it is a big job.
Yeah.
There's a lot to keep track of.
Yeah.
It's fun. It keeps you occupied.
Oh, absolutely fantastic. If people want to follow the work that you're doing, where should they go?
So toward the end of those slides, I have a couple links that you can go.
Okay, we'll put those in the show notes.
There's a suit up link. And then a lot of our technical work is published at the International Conference on Environmental Systems.
Yep.
And so that's available to the public for free. You just go to the conference proceedings and look up papers about our spacesuits, and you can see what we're doing.
Wonderful. Well, Amy, thank you so much for taking the time to chat with us today. Very inspiring work, and I cannot wait to see one of these on the moon or Mars or both.
Yeah, I can't wait either. I'm excited.
Thank you so much.
Yep. Thank you, Fraser. Bye.
All right, let's move on to the news portion of the episode. Molly will give you a break, but so you can see how it's done. We'll start with Pam, because Pam, I'm excited about all the really cool space stuff to look at this week. What's this month?
Lots to be grateful for. Lots to be grateful for this month. You can see all 5 of the bright planets, and the bright planets are the ones that are visible naked eye. That would be, and I'll just go through them like evening and then into morning. East to west, we see Mars, Saturn, and then Jupiter. So if you're, kind of facing southish from the northern hemisphere, you'll see Mars far to your left, and then you'll see Saturn and Jupiter heading west. They're kind of like the sun does; it sets, and Mars is going to be up at most of the night for the whole month. You'll watch Saturn and Jupiter kind of get closer and closer, and in fact, in December they're going to be like on top of each other. I think it's less than a degree apart. Isn't that what you see?
I'm gonna image that. They're close up together. I'm gonna be able to image it in my 8-inch Schmidt-Cassegrain.
Wow.
December 21st when they're real close together.
Yeah.
I'm like super excited about that.
Very cool. And it doesn't happen very often. So absolutely, if you just do one thing this year,
yes,
go and look at that in December.
Well, but I feel like we've been talking about this for like more than a year now, Pam, and this is it. We're almost there. We've almost arrived.
Almost. But before then, like on the 13th, and this is a telescopic object, Jupiter and Pluto will be together. So Jupiter's a really great kind of guide to find these dim things. That's going to be kind of in the south. And then on the 14th, there's a comet in the sky. Comet C-/2020 M3 Atlas. Its closest approach is going to be on the 14th. Now, this is something you're going to want binoculars for, and you should probably try and find some dark skies for that. It's not a naked eye object. That would be looking in the east. Right. Now, November the 19th, Jupiter, Saturn, Pluto, and the Moon are in conjunction. Again, Pluto's pretty dim, but if you use, binoculars, telescope, that kind of thing, you can pick up these more dim objects. And that, I said it's east, but I think it's going to be in the south. Notes. Then Neptune and the Moon are in conjunction, but that's also something, use your telescope for. The 25th of Mars, 25th of November, Mars and the Moon are in conjunction. That's more east. And Moon is is bigger then. So yeah, look for that. The 27th, Uranus and the Moon are in conjunction. Uranus is another one you want a telescope or binoculars for. That's going to be looking east as well. Then we switch to the morning. In the east for Mercury and Venus, November the 12th.
I'm going to have to take your word for it that Mercury is a place.
I know, sorry. I love looking for it because it's hard,
Yeah.
if you do have kind of a low horizon,
It's
absolutely
always hiding behind mountains. It's just not
absolutely
fair.
try to find that. And the great thing about November and December, a lot of people have more clear skies than normal because it's kind of colder. So yeah, November 12th, that's going to be Venus and the moon in conjunction. Basically, look east before sunrise.
Yeah.
Then on the 13th, the moon shifts down and it's by Mercury. So those two are in conjunction again before sunrise in the east. And we have a meteor shower still this month. The Leonids, super early though, like 4 a.m. on November the 17th. You want to look kind of east-southeast. It's basically near Leo.
So
Leo
how does that balance up? We've got a new moon coming up this weekend, so it's going to be pretty good, I guess. Quarter
17th.
moon will go down. It should be okay.
Yeah, it's always a factor. I didn't look it up
Yeah.
specifically for this one.
Yeah.
But we've had 2 meteor showers this month, so something's going to work. And these aren't as frequent as some of the other ones, but some of them are super bright. I mean, they're like.
The Leonids are, in my experience, the best meteor shower historically that I've ever seen when they're good. But
okay.
I don't know if you saw the one. Do you remember the one back in, I think it was like 2003? There was like a Leonid meteor shower that was just off the hook. It was just.
Oh, nice.
Yeah.
Yeah. Some of these have a cycle.
That's right. Yeah.
They're better at the one point, and then they're kind of dimmer, and then again at the 7-year mark, something like that.
Yeah.
I know one of these too this month was like that. And then we have on November the 30th a partial penumbral lunar eclipse, and they don't really look eclipsey.
Yeah, boring.
Yeah, except for like at the kind of major part. That's 1:45 a.m. for about an hour.
Yeah.
But that's going to be, as the full moon's rising.
Yeah.
You can start to watch.
It's going to get slightly darker.
Right.
To see. It's not one of the really cool deep red ones.
Yeah.
No. But I suppose if you took a series of photos, and I remember talking about that before too, you would kind of catch the dimming and then it brightening again. So you kind of see where that is. And yeah, this is a really great time if you're getting into this or you haven't been out lately. Take a look. It's going to be very, very fun this month.
Yeah, it's just this great combination of a lot of planets close to each other, both in the evening and in the morning. The moon making its way through it, and the planets getting, and again, Jupiter, Saturn, like you want to be more organized. This is an event that happens. I'm going to say on the order of decades.
I don't know.
Like this is not. This is Venus transit level of excitement that you should be having to be able to see Jupiter and Saturn together in the eyepiece. So,
I agree totally. I've got a list here. I'll go ahead and add that to the video after it's been published.
Wonderful, great, awesome. Thank you. All right. Oh, Amy, you can close the Zoom window if you want. If you want to watch the show, that's totally fine, but you're also free to close the Zoom window if you want and enjoy the rest of your evening. We don't trap you. I just forgot to mention that before we started the show. So your call. If you want.
It's interesting. I'm enjoying it. Thanks.
Oh, okay. All right. Well, then stick around. And apparently we are now live on the internet. So all the people who missed the beginning, we apologize. It's only in our memory now, but I'm also recording. It should be available after, I'm sure. All right.
I see it now.
Yeah, that's what people are saying, that they're able to watch it. So that's great. All right. Brian, what have you got for us?
So this is a story about Trojan asteroids that are near Mars. And if you think of Trojan asteroids, you probably think of Jupiter because most of the Trojan asteroids are near Jupiter. And the reason you have Trojan asteroids is because of a kind of gravitational dance between the planet and the sun. Because the planet is orbiting the sun, the gravitational pull between both of them and the rotation means that you get these kind of gravitational potholes on either side that are called Lagrange points. And the Earth has them, Mars has them, all the planets have them. But in the case of Mars, that means that about on 60 degrees ahead and 60 degrees behind where Mars is, there's these little gravitational potholes, and little asteroids tend to cluster there. So you get a little group of Trojans in front and a little bit of Trojans in the back. And one of the things is, where do these come from? And because Mars is close to the asteroid belt, you might say, well, maybe some of them strayed a little too close, they got trapped, and that's why you kind of get this debris field. But if you look at what the chemical makeup of these Trojans are, then you can kind of identify them. And this is a common thing where you look at how the light is reflecting off of the surface of an object. And what light actually reflects off that surface depends upon what the chemical and mineral composition of that object is. So you can actually identify some of the things that make up that object by looking at the light reflecting off of it. So when you look at the Trojans for Mars, what you get is that there's a group of them that are called the Eureka group. And the spectrum of light reflecting off of them looks very similar to the spectrum of light you'd expect from Mars. It's high in a mineral called olivine. And so the popular theory is that these Trojan asteroids are probably fragments from impacts on Mars that were thrown out and then happened to get caught in this gravitational well. And so they originated from Mars and impacts with other asteroids with Mars, which kind of makes sense because it's the closest body to where these Trojan clusters are. So it kind of makes sense that that's where they would be clustered.
And doesn't that sort of also connect with the story of maybe where Phobos and Deimos came from, that there was some impact event that helped form them and also kicked out these Trojan asteroids into this orbit?
Right. That's the theory that kind of leans now. The earlier theory that they were captured asteroids. But the impact idea seems to make a lot of sense. So yeah, all these types of things is that, it's easy to throw debris off of Mars because it's a fairly small planet. It doesn't have a thick atmosphere. And because of these Lagrange points and interactions, it's easy to kind of capture them. So they were looking at the spectra of these, and there was one of them that has a name that's only a number. It's 101429. We come up with these great names. But they were looking at the spectrum of this one, and it isn't as similar to Mars as the other ones. So it's not part of the Eureka group. In other words, it's not from this comet event, if that's what would have caused them. What's really interesting, though, is that when you look at the spectrum of it, the mineral content is different. And of the bodies that it matches best, the moon is the best candidate. So if you look at the spectrum of the surface of the moon, and you look at the spectrum of this Trojan asteroid, they match up relatively well. That's because it has a higher content of something called pyroxene. And yeah, so you can see the spectrum, they're reasonably close. So this kind of hints to the idea of, could this actually be sourced from the moon? Could there have been an impact on the moon that threw debris out towards Mars, and one of these happened to get caught in the Lagrange point? If that's the case, that would be kind of interesting, because we know that fragments from different planets can cross. We have meteorites that have landed on Earth from Mars. So we know that actually happens.
And Vesta.
Yeah, I have a little fragment.
Actually. Oh, do you? Okay.
I have a fragment of Mars. It's so cool.
That's
yeah,
amazing.
it's not that big, and it's already run through the lab before I got it, but I don't care.
Yeah.
What's the thing is that when you have something from Mars, Mars has a low gravity, and it's easy to get things off, and also it's easier to move things like asteroids inward than it is outward, because you already have the energy to kind of move in. Gravitational interactions can kind of bring them inward. So that's why we have more drift from Mars to Earth. Do we have drift from Earth to Mars? As far as we know, there isn't. But the moon has a small gravity, so it's possible that it could have gotten enough energy from some impact to get it out to the orbit of Mars. And so that type of dynamic both ways is very interesting. The one thing, go ahead.
Oh, I was just going to say, like when we kind of imagine the Trojans, we imagine the the bottom of this valley like a, I don't know, like a lint trap that collects all this stuff, but it's actually an area that things orbit around. So you're not necessarily going to have, it's there's nothing actually down at the very bottom of the gravity well of the L4 L5 point. It's just that it's a place that things are able to orbit. But I mean, what kinds of gravitational shenanigans would have had to have happened to get a chunk of the moon into the Martian Lagrange point?
So you would have had to hit the moon in such a way that fragments would have actually quite a bit of energy. They would have to escape the gravity of the moon. And since there are no large bodies in between, they might have gotten a flyby effect from the Earth, but they had to have enough energy to go outwards. And then they had to interact with Mars in such a way that it didn't just fling past. You can fling something out there, but then it also has to have just the right trajectory so that it slows down to stay in one of the Lagrange points. So one of the things that can happen is you could go through a Lagrange point and just keep going.
Mm-hmm.
You kind of speed up as you went into the dip and then slowed down and you just kept going. If you have too much energy, you can't do that. So it tends to be things that are fairly slow relative to Mars. So if you're kind of crossing the Martian orbit with a slow speed, well, then relative to that little dip, you now are kind of stuck. So it's that idea that you get that lint trap,
Right.
Couldn't the sun be pushing stuff like, the solar sail concept?
With small things, yeah. So you can have the solar wind interactions, but they get weaker as you get further out.
And on the flip side, I mean, you've got the interactions of Jupiter, which is jiggling the asteroid belt, shifting stuff inward, which is where we get all of our near Earth objects. But to imagine something going in the opposite direction, going outward, is kind of fascinating.
Right. You have to have enough energy to do that because of the gravitational perturbations between different objects. Usually one of them loses. Like one will gain a little bit of energy, but the other one will lose a little bit of energy. So that one moves inward. And then when it interacts again, one of those loses. So you kind of have a 50% chance every time to move inward and you're not going back outwards.
Right.
So it's kind of hard to go uphill, as it were.
Yeah, it's funny when you we imagine when we look at the solar system, we look at the sun and we look at the planets going around, it's like a record player or whatever. And we kind of imagine like something shifting from one racetrack to another in this, in these various orbits. But it is a hill to go from the Earth out to Mars. You are climbing a mountain to get there. And then to go past that, you're climbing a mountain. And so it does require a lot of energy, and yet the perfect amount. I wonder how much of this material, I mean, these Lagrange points are such a fascinating place. And that's why NASA's got its Lucy mission, because you can do on one trajectory, go past 8 different objects in the 2 Jupiter Trojan points. But I just wonder if you could build some kind of thing that just hung out in one of the Trojan points, just orbiting around and around and around and just making flyby after flyby after flyby. I mean, there's a lot of interesting lint collected.
We've done that with some satellites where we do with Earth's Lagrange points.
Yeah.
So we'll plant satellites near there because it tends to keep them in a regional spot. But, Mars the Lagrange points of Mars are relatively small. So because it depends upon the mass of the planet for how strong these are. That's why Jupiter has most of them, because Jupiter is a huge planet. So its Lagrange potholes are actually pretty big. They're pretty strong.
Well, there's as much material in Jupiter's L4 and L5 point as the asteroid belt.
Right.
It's like a whole other asteroid belt.
Yep.
That people don't even realize. So,
wow.
Yeah, absolutely fascinating, Brian. Thank you so much.
Sure.
All right, Molly, your turn. What have you got for us?
All right. So getting into some even more sciencey things. When was it? Last Thursday, a paper was published in the journal Nature, which is a kind of the premier science journal. that a fast radio burst was detected within our own galaxy. And that's the new part, is that it's within our galaxies. Most of the fast radio bursts we have observed have been in other galaxies. So what is a fast radio burst? It's a short duration pulse of a really strong radio signal. And we don't exactly know what causes them yet. And although we're with the recent one that we just got in Milky Way, now we have a better idea of what type of object causes them, even if we don't know exactly how that object is causing them. So, and then of course, radio, as a reminder, is really just long wavelength and low energy light, but these sources shine a lot of it. So it's like having a really bright flood lamp instead of a dim reading light or something like that. It's the same wavelength, but much brighter than other radio sources. Fast radio bursts put out so much energy, even though it's low energy light, but it puts out so much of it that the average fast radio burst outputs as much energy in 1/1000th of a second as the sun does in 3 days. It's a lot of energy in a very short period of time.
Right.
So a lot of fast radio bursts are not repeating, although some of them do repeat. Like there's one that was discovered in 2018 that pulses every 16.35 days on the dot. And that one lies in a galaxy about 450 million light years away. Some of the fast radio bursts we've seen have been even further away in galaxies billions of light years away. So some ideas of what might cause these fast radio bursts are potentially a rapidly rotating neutron star black hole binary system. Could also be compact object mergers. So so neutron star and a black hole merger is a type of compact object merger, but there's other types as well, like two black holes and two neutron stars and things like that.
But I guess the mystery with those is you would also expect to potentially see the radiation in some other part of the spectrum as well. Like as we saw with the kilonova, we detect the gravitational wave merger, but we also detected the flash of X-rays and visible light from that collision. But we're only seeing this flash of radio waves, right?
Well, in this case, the other special thing about this new discovery was that we didn't only see the radio signal, we actually saw the X-ray signal too. And that's how we were able to, the scientists who are working on this project were able to trace this fast radio burst to a specific magnetar, which they've not been able to do before when it's been in other galaxies and we can't resolve individual magnetars. So in this particular one, they had been observing it in X-ray telescopes for the prior 12 hours or so because it had been acting up. It was spitting out all kinds of X-ray bursts over like a half second or a second, these pretty short bursts. And then this was some NASA X-ray telescopes that were observing this. And then 13 hours later, when it was on the other side of the Earth, several European, Chinese, and Russian X-ray telescopes picked up a really short pulse that was only a half a second long of X-rays. And then at the same time, two radio telescopes picked up a millisecond long burst, so 1/1000th of a second of a radio burst from the same source. So that discovery has meant that now we're pretty sure that at least some fast radio bursts come from magnetars. Now, what is a magnetar? It's a type of neutron star, and a neutron star is a very dense star left over from a supernova where the core has collapsed and has been compressed so much under gravity that the material of the neutron star, is actually as dense as an atomic nucleus. If you had a matchbox full of neutron star material, it would weigh 3 billion tons here on Earth. Neutron stars are incredibly dense. They're only 6 miles across, and yet they're also 1.5 times the mass of the sun, compressed into a much smaller space. And magnetars have really strong magnetic fields around them. And sometimes they're spinning, and those magnetic fields are moving like a lighthouse, and those are pulsars. But the magnetic field is so strong, it's what did I put down? It can be between 1 billion let's see. No, it's actually 1 to 100 trillion Tesla,
Right.
which is a unit of a measure of magnets, magnetism, which compared to the Earth has an average magnetic field strength of 25 microtesla, which is 25 millionths of a Tesla. So as a way to kind of like a strong magnet on Earth is 1 to 10 Tesla, and yet this neutron star has a magnetic field of trillions of Tesla, which is like crazy.
So definitely don't bring your hard drive too close. Don't bring your credit cards too close. They're definitely getting demagnetized.
Yeah, for sure.
Yeah. And so based on this observation, like, is it like the perfect fast radio burst? Like, does it really match the signature of the fast radio burst that are being collected up until this point? Like, can we just say definitively that's it? Fast radio bursts are magnetars?
At least some of them are.
Some of them are.
So the research that, like, when they analyzed the dispersion of the radio signals across multiple frequencies and looked at the brightness of that source versus its distance, because we have a rough estimate of how far away this magnetar is, somewhere between 14 and 30,000 light years away. It looks just like a fast radio burst would from a more distant galaxy, which we've measured many times before. So it's for sure a fast radio burst that's the same type as the ones in these other galaxies. Right. And because it matches up with this known magnetar, then we can say that at least some fast radio bursts come from magnetars.
Do we have any idea of the mechanism that's actually causing the burst part?
Not that I saw when I was doing research on the article. That still remains largely unknown what the actual mechanism is for producing this fast radio burst.
Brian, I don't know if you have any additional info on that.
Well, right now the leading idea is some type of magnetic snap. So just like with a solar flare, you get this you get this kind of twisting of the magnetic field, and then when it realigns, it snaps into place. You get this burst of energy. The difficulty with that is that while the sun is very fluid, it has very different layers. Neutron stars, at least so we thought, don't. And so that type of, we're not sure how you would get that twisting that would cause the rapid snap. We know that can produce that level of energy, but how it would twist into place is very speculative.
Right. Molly, you had another story as well. So why don't we go to that while we still have a little bit of time left? But that is super cool. Just to sort of finish this up, there's a lot of these big mysteries. There's dark matter, there's dark energy, there's like, why do we dream? There's all these big mysteries that we may not ever find out the answer. But this idea of fast radio bursts, it feels like one that is in our grasp. Like, it showed up within the last decade or so. Very confusing, very mysterious. People are starting to point their telescopes at it and get to the bottom of this. And it's quite, it feels very satisfying to see an answer come together in a reasonable amount of time, as opposed to just a whole bunch of people just scratching their head going like, I don't know.
Yeah, the first one was just discovered in 2007, and they estimate that I think I read somewhere they estimate that there's 3 per day happening somewhere in the observable universe. So they're relatively common events, but yeah, it is really cool that it's a mystery that we're solving pretty rapidly since its discovery initially.
And we have the greatest observatory to catch them, which is the Chime Observatory here in Canada, just a few hundred kilometers from where I live.
That's one of the 2 that measured the signal, was the Chime Observatory, which is, for people unfamiliar, it's a series of 4 basically half-height radio dishes, more or less, that are on the ground, that they're 330 feet long and 65 feet wide, and they observe in the 400 to 800 megahertz radio band.
Yeah, you can get some sweet air on those.
They weren't like all slats.
Exactly, yeah. You got to get a good snowfall, good ice, yeah. All right, well, let's move on to the other story quickly about Europa glowing in the dark.
Yeah, okay. So Europa is one of Jupiter's 79 moons, and it's the smallest of the 4 Galilean moons, the ones that you can see really easily with a pair of binoculars or a telescope. And it's the 6th largest moon in the solar system, and it's only a little bit smaller than our own moon. Now, Europa is a very fascinating moon to begin with because it's extremely smooth, and its surface is made of silicates and water ice. And because it is so smooth and not asteroid or meteor pockmarked and other variations, it's thought that it has a subsurface ocean made of water. I'm not talking like a methane ocean, I'm talking a water ocean that because of, and it's kept in a water state because there's heating from tidal poles and from I like the tidal poles from Jupiter and tectonic activity and things like that. So there's potentially liquid water on just underneath the surface of the moon. Now, Jupiter has an extremely high radiation field caused by lots of charged particles being accelerated in its intense magnetic field. And we know that when you irradiate a lot of molecular compounds and atoms with radiation, then they'll continue to glow afterwards, re-emitting that light in sometimes a visible light. And we know a lot of salty compounds, we know their colors very well, that they would exhibit from radiation. The new piece with this is that NASA's Jet Propulsion Laboratory, somebody thought to try it on salty ice, like you would find on the surface of Europa with like Epsom salts and table salt and salt compounds you might find on the surface there with the briny ice. And they did glow like they expected, but the glow was actually a different color, a different spectral composition than their liquid forms, which was new and unexpected. And because of that surface ice on Europa, they think that the night side of Europa might be glowing in white or green or blue or colors that they saw from bombarding the ice with radiation, which is really cool. And the Europa Clipper mission that's set to launch in 2025 will be able to observe this potentially, among many other things it's going to observe about Europa.
Really interesting. Well, we've reached the end of our show. So, Molly, you're on my screen. So why don't you go first and let people know where they can find out more and what you're working on?
Yeah, so I do a lot of astrophotography. So you can find my astrophotography stuff at astronomolly.com. I will at some point be posting on there some of my more scientific pursuits as well. I've been doing a lot of variable star astronomy recently. This is all in my amateur capacity, as opposed to the science I'm doing for my actual PhD, which I don't really have much written up on yet. But yeah, astronomolly.com or on Facebook as Astronomolly Images, or on Instagram as astronomolly_images.
You're one of the first academic astronomers I've ever met who actually knows her way around the night sky.
Yeah, a lot of astronomers who are professionals and scientists, they're not sitting out there operating their telescope and looking at star charts and stuff like that. They're kind of existing in a different area of the science. So yeah, it's kind of a unique position.
Yeah. Brian, what are you working on?
I'm working on stuff for NRAO mostly right now. And in terms of where you can find me, you can always find me at my website, which is briancoberline.com, or on Twitter at briancoberline. The name's unusual enough that I'm pretty much easy to find. Excellent.
And lots of great stories for Universe Today, like this one you just talked about.
Absolutely.
Pam.
Very cool. I'm going to show this because my book never shows up. I wrote this book. It's Your Amazing Itty Bitty Explore Space Now book, 15 Simple Ways to Personally and Directly Participate in Space Exploration Right Now. We have a show on Friday nights now. We've been doing for a couple months. Jeff and I will talk about a couple topics and basically say what's going to happen in the night sky like I talked about here. And we started having guests. We had a really good time with our buddy Cliff Butson from Australia. And we have one already scheduled for later this month. And we're just having a lot of fun talking to regular folks about the things they're doing. And The next person, Christina, she's fairly new at it. And I'm like, well, this is great because, I've been at it since 1991 and I don't necessarily remember how it was to be new. So it's going to be really exciting to talk to her and find out from her perspective what kinds of things would be really interesting to someone who's very new at it. I just love that Molly is an observer. Some of them have said, I've never looked through a telescope and I'm very proud of that. And I'm like, but you're missing so much cool stuff.
Yeah. It's so funny to have that conversation with professional astronomers, and it starts to dawn on you that they don't know their way around the sky.
There's nothing quite like seeing the moons of Jupiter or the rings around Saturn for yourself, looking through a telescope.
Totally.
It's a very intimate thing, and it's a very exciting thing. And I love watching people when they're, oh my God, is that a sticker on the end?
Yeah, when they see Saturn for the first time. Yeah.
Have you heard that, Molly?
Yeah. My 8-inch Schmidt-Cassegrain pulls down fantastic views, especially of Saturn. And when the seeing is really good, people are just amazed. And I've even thought, like, that looks like a picture, it's crazy.
Yeah.
There's something quite like the realization that photons that have been traveling for tens of millions of years and across tens of millions of light years of space that were emitted by some star 10 million years ago are being absorbed into your particular retina. Like, that's just a completely magical feeling that is not, even though looking at the objects in astrophotography lends its own beauty, it's really a special experience.
Totally agree. Yeah, if you're ever in our area, come to our site. We can see the Milky Way from we're really close to LA, but I can still see the Milky Way out at our observing site. It's really neat. Like, anybody from LA can just drive out and take a look. It's so cool.
Sounds
That's
great.
awesome.
All right. Well, I'm going to put everybody back on the screen so we can all say goodbye. The next thing that's coming up, of course, we've got the virtual star party. Actually, we've got Astronomy Cast on Friday. We've got the virtual star party on Saturday. Remember the earlier time, 7 p.m. Next week on my channel, I'm going to be interviewing Chris Carr, who's one of the co-hosts on the Weekly Space Hangout. So we'll get a chance to go deep into his background, extragalactic astronomy, what he's researching, and hopefully you'll be able to sort of learn a lot more about him as a scientist and journalist. All right.
Sounds cool.
Everybody's up on the... Wait, where's everybody? There we all are. All right, so thank you, everybody. If anybody's actually watching this, thank you for joining us. Thank you for... thanks to Nancy and the rest of the moderators who had a very easy job this time around. Thanks to my co-hosts. And our special guest. We really appreciate everybody. Hopefully, I won't have to upload this after the fact. It'll just work, but we'll see what happens. Let me know if it's busted, if the first part of it is broken, because you definitely are going to want to go back and watch the interview. All right, thank you, everybody, and we will see all of you next week.
Good night.
Bye.